and I'm live. That is cool. Today is 29th of August 2025, Friday, and that is cool. I'm using center stage. So, see, there's this feature called center stage in Apple iPhone, and this seems cool. And yesterday was a contest in which I was able to do the first two questions, but I wasn't able to come up with an algorithm to solve the third question. And apart from that, okay, my headphones are connected. That is cool. And apart from that, the algorithm to solve the third question is pretty elegant. Okay, yep, yep. The one that I was unable to solve was the first question in division one. So that is cool. This is shit. This is division one against by the assignment. Yes. Yep, yep, yep. It was the first one in division one. So that is crazy. And the algorithm to solve it uses dynamic programming. And I read the editorial and implemented this solution. And this was a bit hard to see, but definitely it does work. It does work, which suggests to me that I have to do a lot of work on my dynamic programming skills. Now, with that given, let's begin solving CB31. 1400 rated questions. Next one would be this one. Yesterday we did four questions, and yep, to summarize the four questions, there was this one. Step 0, 1, 2, 3, and yes, this one used dynamic programming with BFS search. Yep, that is what it was. And let's see the tags. Yep. DFS or BFS, DFS and similar. Yeah, BFS. I used BFS and dynamic programming, and graphs and trees are the thing, right? Yep. So that is cool. I remember what I learned. So that is important. And then in this one, what was this? I had n friends, m pairs, and yes, some were friends with each other and some were not. I would call this also used dynamic programming and constructive algorithm. Let's see the tags. Dynamic programming, constructive algorithm. That is cool. And two pointers. I guess you could say two pointers, but binary search does not make sense. And then make it round. Yes, 0, 0, 0. Greedy. This used greedy algorithm. Or brute force. Well, this was number theory, but yeah, I used greedy algorithm. Like you can call the algorithm greedy. And add modulo 10. This one, what would I call the algorithm that I used in this? I took the last number. I would say number theory is the fine thing. Number theory and constructive algorithm. Number theory, maths, brute force. Yeah, yeah, brute force. Brute force is fine. And now today we have to do this schedule management. That is cool. And stopwatch ready. And this was the thing in yesterday's contest. Question number third, this thing. That is cool. Dynamic programming. Yo. Okay. And tmux, kill server, tmux, set to start my tmux session, and attach TCP. Here I am. Let's go to the folder or to the directory. Folder is not the right word. Like good people do not say folder, they say directory. Update everything. Yep, and we are good to go. Are we good to go? Yes, we are. There are n workers and m tasks, and also I can put this thing up. There are n workers and m tasks. The workers are numbered from 1 to n. Each task has a value ai, okay, till am, the index of worker who is proficient in this task. Every task should have a worker assigned to it. If a worker is proficient in the task, they complete it in 1 hour. Otherwise, it takes them 2 hours. The workers work in parallel independently of each other. Each worker can only work on one task at one time. Assign the workers to all tasks in such a way that tasks are completed as early as possible. The work starts at time 0. What's the minimum time all tasks can be completed in? And M is always greater. Okay. And the values are in N and there are M values. So I can, yeah, and the order does not matter. I only have to see how many tasks. Count, count. Yes, how many workers have tasks and how many workers do not have tasks. And pigeonhole principle, there will always be a worker which has multiple tasks, right? A worker which has multiple tasks. Yep. In this 1 and 1, there is only one worker and he does the first task, that is who. There are 5 tasks and 5 workers. So each of them does one job and we are cool. Here, yes, there are 4 tasks and all 4 of them should be done by the first worker. So in the first hour, in the first hour, I will assign worker number 1 to some task and all the other tasks would also have workers which should be assigned to them, right? Yep. And then the remaining number of workers and the remaining number of tasks will do something and it will take them 2 hours. Right. So in the first hour, I will be done with this task and the other remaining 3 workers will do half of these. And then in the second hour, they will complete them. So the time, there are only 2 workers. Okay, so this one worker in the first hour does this, in the second hour does this, and this is also completed at the end of the second hour. And this one would be done by the best worker. Yeah, by worker one number 1. And here too. So 2 hours. That is correct. Greedy. Yep. N and M. There will never be workers who are left over. Pro-efficient, not even efficient. The sum of M does not exceed this. Okay, so the order of these things doesn't actually matter. All I have to remember is I can make this array of size n+1, and whenever I see something in that, what would be the worst case? Worst case is this. Right. I can take this and sort this. Skeletra. Okay. First, I have to decide on the data structure which I will use to store all of this. And for this thing, for storing this second part, I do not need to remember the order in which they appear. That is cool. And something like this, if I have 5 workers, then 1, 2, 3, 4, 5 vectors. 5, yeah, a vector of size 5, and this will say 1, 1, 1, 1, 1. That is how many tasks these workers are efficient. And yep, in how many tasks they are efficient. And in one go, all of them should be assigned to some task in which they are efficient. If mm, if they are efficient in some task, then it will take them this amount of time. Yeah, if they are efficient in one task, then they should be assigned to that task. And if they are not efficient in task, let's say if this was 0 and this was 2, then all of these would be assigned one of the tasks in which they are efficient, and there would be a task left over. Let's say this was 2, this was also 2, and this was also 2. Now, after going through this once, quite a bit of tasks are done, but there are 3 tasks left over and 1 worker who is not efficient. So I can assign one of these 3 tasks to this worker. Yes, and say, yeah, and it would be equivalent. Let's say this task that was assigned to this worker 5 was one of the tasks in which this second worker was efficient. And at the end of the first hour, in the first hour, this task was this one was done. This got completed, and one of these was completed. One of these was completed, and one of these was completed. And I assigned to 5 one of these tasks. So half of this one is also completed. And now it would be bad if I were to assign the same task to 2, because from this point 5 will take 1 hour to do this task inefficiently because he has already spent 1 hour on that task, and 2 would also take 1 hour. Mhm. And what I could do is assign one of these tasks to 2. No, I don't have to. I don't have to. The total thing in this would be 2. Answer here would be 2. If I have just 2 workers and this one is efficient in 4 tasks, and in total there are 6 tasks, and this one is not efficient in any of the tasks, then out at the end of the first hour I would have done one task. 6. Okay, maybe I can simulate, but simulating can take time. Okay, I can represent this in this manner. 1, 2, 3, 4, 5. There are 5 workers, and let's say this one has 3 tasks. 1, 2, 3, 4, 5. And this one has no task. This one is efficient in 1 task, and this one is efficient in 2 tasks, and this one is also not efficient in any of the tasks. And let's say this one is efficient in 4 tasks. And I will have my time simulator. So at the end of every odd time, I will subtract 1 from the 1. Yeah, I will subtract 1 from all the tasks that are done by workers who are efficient in them. So at the end of 1 hour, this one would be done, this one would be done, this one would be done. And then I go to t plus 1, that is 2, and 2 is even. At even time, I will, of course, subtract the tasks like this. I will subtract this and this, but also I have the ability to subtract more tasks. I can, at the start, I had only 2 workers who were empty and not doing anything. Okay, I can maybe have a counter. Yes, I can have a counter which tells me how many people have efficient tasks assigned to them and how many people don't have efficient tasks assigned to them. Right, there are different states. One state is efficient person doing some task. One state is non-efficient person who has just started one task. Like he is not in the middle of doing anything, and a non-efficient person who is in the middle of a task, like right here. But how do I know that? For that, I would have to check all of these, and I would have to go through this list again and again. And what is the maximum value? 10 power 5. In the worst case. Okay, it is cool. It is cool. Because I do not have to keep anything for this, for this. I can keep a map in which a map of pairs in which the first thing would be the index and the second thing would be this count, and I can keep going through that map. Yes, and if someone has done all their efficient task, then the size of the map reduces, and yes, I won't have a lot of elements to go through, but still it very borderline feels like n square time complexity. But in every pass, let's say even in the worst case, if, yeah, in every pass I'm just going through fewer and fewer elements. Yeah, that is good. That's good. Uh, Feels like it would work, even though I do not have a complete understanding of what I am trying to do. But it feels like I do have something. And add m. Yep. I have n and m. And now I can create a map. pair of int to int. Let's call it MP bots. Huh? Two. Okay. Shit. Shit. A map from integer to integer. Int I equals 0, I less than n, I plus plus, and cn and mp c plus plus. mp c plus plus. Increase the count. Now I have all the counts. And I also have the total number of tasks. Yep. So while n m, I will iterate for auto x, for auto I c I x in mp. What I will see is I is the index and x is the count for that thing. And shit. Okay, and I need to keep track. What is the invariance in every pass? In every pass, what is the invariance? I need to keep three things. First is this, right? First is this, which is the number of people who have efficient tasks, which I can get from my map. That is cool. And then I have to differentiate between these two things. Non-efficient people who have just started some task, or non-efficient people who are in the middle of doing some task. And I can call this int me middle efficient mne middle non-efficient equals 0. Initially, no person is in the middle of doing a non-efficient task. Right. And yep. So okay, I have this count, number of people who are in the middle of doing a non-efficient task, and people who are doing, or who have to be assigned, efficient people who have to be assigned a task, and non-efficient people who also have to be assigned a task. And okay, so at every pass, I will see how many tasks have been done at this point that I am at, and then assign tasks to these people. Yep, assign tasks to these people. Then also assign tasks to these people, and actually put these people in this category. Put these people because when I make another pass, shit, non, how do I see how many people have done their task? Hmm. Okay. I will assign some task to these people, or I can say that the number of efficient people would be subtracted from the total number of tasks. Okay, I will simulate a whole second. I will simulate a whole second that I'm at. Okay, I will simulate a whole second. So number of efficient people will be reduced from the total number of tasks, and number of non-efficient people who are in the middle of some task would also be reduced from m, the total number of tasks, and number of non-efficient people that are in the middle of a task would become equal to this number. Yes, would become equal to this number. Yes. And I would also have to update this number, and this number would be the sum of the previous this number would be the sum of the previous non-efficient people who were in the middle of a task and the efficient people who have completed all of their efficient tasks. And there we go. And at some point, m would become equal to 0. Okay, I have this thing. So first of all, m minus equals m and e. Right, that thing is done. Cool. Middle of the task, non-efficient people. And now all size. Uh, m minus equal. First, I will, yeah, m minus equal mp dot size. Right. These are the tasks that would be completed at the end of this current time block that I am at. It would be equal to the number of efficient people and the number of non-efficient people who are in the middle of a task. And now what I have to do is update this number of non-efficient people who are in the middle of the task, which would be equal to this number, that is the number of non-efficient, and this whole thing totals to n, because some of the workers would be doing some efficient task and some of the workers would not be doing some any efficient tasks, and some of the workers would be in the middle of some efficient tasks. So I know this number, I know this number, I can calculate this number. Yes, I can calculate this number. Did you took part in your studies? Yep. Yes, I was able to do 2 questions, but not the third one. Third one used dynamic programming, and now I looked at the editorial, and now it seems easy, but it doesn't seem easy. But I don't know how someone would be able to come up with a solution to that thing. And the crazy thing is, the third question in which I got stuck was the first question in division 1. Yep, right here in division 1. This is the question on which I got stuck, and this was division 1's first question, which is messed up, which is crazy. But now I got it after reading the editorial, and I would have to review this question a few times to make sure that I understand this. And getting back to this, I have M and E, and okay, I did update my M, and I need to update E. Let's update E. Yes, let's just update E. So I will have the updated value of E, and I have the old value of NE, MNE. I have that, I have that, and all the number of, yes, MNE would be updated, would be updated, would be updated to be equal to NE, non-efficient people who were not doing anything. So MNE will get the value of NE, and NE equals the original value of E plus MNE subtracted from N. Yes. No. MN, just MN. Okay, I will update E. Okay. Uh, Any and NE would be equal to N minus MP dot size plus MNE. MP, no, no, no. The size of MP will be reduced. Yes, this is correct. MP dot size is the number of people who have some efficient task for them, and MNE is the number of people who are in the middle of some tasks. And if I subtract that from the total number of people, I will get the number of people who would be in the middle of their task at the end of this current second. And now, yes, wait, shit, wait, this is correct. This is correct. This is correct. Can I do this? I can do this. Yes, 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 yes. I can. Because by the end of this second, what all I have to do in this particular second is simulate, right? And M subtract from M the number of people who were in the middle of their task, and subtract from M the number of people who have some efficient task which they could do, right? So that is the maximum number of people who would have done their task, and the number of people who are not efficient with their task would be equal to this N minus MP dot size, number of people who are efficient with their task, and number of people who are in the middle of their task. And when I am finished with this second, that is the number of people who would be in the middle of their task by the end of this thing. So x minus minus auto reference. If if not x, if x is now 0, then I can remove mp dot erase I comma x. Ah, yeah, yeah. Shit. Okay, okay. Sig fault. Okay. Mm. How do I erase vi delete, and I will have to delete this. delete dot pushback I. A stack would be better. Delete, and a better stack would be vi dot push I. Now again, while not del dot empty mp dot erase del dot pop del dot top and del dot pop. Okay, wow, it keeps on running. While del dot not empty, I am mm, 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 mm. While m greater than equal to 0. While there are tasks. Okay, first one is wrong and also the last one. In the last, I say 2, even though I shouldn't say 2. I also did 2, 4. One was hard. I also tried so much, but was not able to. Yep, third. So, are you solving questions for of TLE or something else? I am stuck at 1100 to 1100 in TLE. I am unable to solve any without tutorials. What extensions you use for test cases? For test cases, I use this thing, this extension. It is called Competitive Companion, and I have a plugin in Vim which helps me, which is integrated with this somehow magically, and they work together. And yes, I'm just solving these TLE questions, which I think is like good, so that I get to see new topics and I can just go afterwards and learn about them. But here is a problem somewhere. Yeah. For this, I'm saying two somehow. Why would I say two here? Because this would become yes, and I would do MP 1 plus plus. So MP dot size would be 1. So M would become 0. M should have become 0. Blank plus plus. The name of the question is C schedule schedule. One test case which has n equal to 1, m equal to 1, and 1. And it was 0, and I got 0 as an answer. Why does it say 2 here? What? Why is it saying 2? I have only one test case which has n equal to 1, m equal to 1, and 1. Why does it say 2 there? I'm seeing 1 here. Okay, let's also test for the first. test case. I have only one test case where 2 is 4, where n is 2 and m is 4, and 1, 2, 1, 2 is the pattern. And hmm, m, m, and a new line, blank or slash out. One test case with 2 and 4, and 1, 2, 1, 2. M was 2, but then in the second pass it was not updated somehow. Why? X minus minus. I can like actually do this. If not minus minus x, right? See out size would be mp dot size blank dot slash out 1 2 4 1 2 1 2. Okay, size was 0. Uh, okay. I the value of I is I, and then value of x is x, and then a new line. Okay. 1 2 4 1 2 1 2. Okay, why is it 1 always? MP1, and it's also put something like this, makes a lot of sense. 1 2 2 numbers 4 1 2 1 2 1. Why is it 1? It should be 2. It should be 2. C out, C, MP, C, clang schedule 1 2 4 1 2 1 2. Ha. Okay, my bad. C space uh count clang dot flush out 1 2 4 1 2 2. Okay, somehow count is because I am very stupid. Because this has to be M. That is the number of tasks that I have. Shit. Okay. Okay. Shit. Okay. It works. It works. It works. Okay, is it going to work? Is it actually what we can do is something crazy which I just figured out. What topics are you focusing on solving to see? Dynamic programming. In yesterday, it was dynamic programming. I was trying to figure out some dynamic programming way to solve the question yesterday, but I was unable to. And then today I read the editorial and I do understand, like I do know how to write the code to solve that question. Like here, 1046 and C. Yep. I wrote the code to solve that question here. And this is the code which this is the correct code for question number C. Even though I have written this, I do not quite understand why how this works. In the tutorial, there was no code. They just explained how it is supposed to work, and I implemented it, and it is working. But I do not understand how someone, after reading that question, would be able to come up with that question, with that solution. I guess it depends on how much practicing I'm doing, and that just tells me that I have to practice a lot more than I currently am doing. And for this question, I'm getting the right answer here. And what I can do to see if I do understand how this question works is just delete the whole code and write everything from scratch. This is a new way that I have figured that I have come up with. Just delete the whole thing and write it again. And what was the thing? This will tell me if I can write the whole code again. This will tell me if I know what I'm doing or if I'm just like pretending to know. So I took taken n and m. Then I create a map to store. Okay, I will not even look at the question now. All I have is this, and from this I have to write the code. So map integer to integer, where first integer would have the index and the second integer would represent how many. The first integer would be the number of the worker, and the second integer would tell how many tasks is this current worker efficient in. So I can do, yeah, for int I equals 0, I less than m, not n, m, no, not n. That is the mistake we did. And C in C and MP bracket C plus plus. Now we have discount and yep, we need time. Time starts at 0 and the number of non-efficient people who are in the middle of their tasks, which is this. And now while m number of tasks is greater than 0, what we will do is reduce from this mp dot size the number of people who did some efficient tasks and m minus equals the number of people who were in the middle of doing some efficient task, who were in non-efficient people who were in the middle of doing their non-efficient task. And now for auto x, auto I x, I is the number of the worker and x is the count of efficient tasks that this worker can do. And I will iterate through this. And if reducing this number, if this was the last efficient task that this worker did, then I will have to remove this thing from the map. And how do I do that? How do I can like create a stack like I was doing earlier, but maybe There is some better way. Stack using a vector underneath. I will call it del. Let's just do it this way and see if it works. And then we can optimize del dot push I so that I know that when I get out, I have to remove I. So now here, while not del dot empty, what I will do is mp dot erase del dot top, erase the top element from del and pop that element from del. That is cool. And also I would have to update the number of mne would be equal to n minus the number of people who were doing efficient tasks. Yes, because they won't be able, yeah, because they will be doing some efficient tasks in this time period, and mne the number of people who were in the middle of their efficient tasks. Yep, that seems good enough. Is there something else that I have to do? The variables I have are del, mne, and t, and map, and I'm taking care of map. I'm doing whatever I have to do with the map. I am taking care of m, and I'm taking care of mne. This seems good enough. Let's see. Okay. Shit. Something is wrong. Yes, of course, something is wrong. Cool, cool. I think this should be cool. Let's see. 47 minutes to do one question. Hmm. Very professional. It is running and wrong answer on test two. Shit, shit. It was a, yeah, shit. Okay, wrong answer on test two. So something is messed up. Yep, silly mistake. No, I didn't submit it. I had to see the tutorial today. Yo. So, okay, let's look at this closely. The variables I am having, I have are my map variable, which what does it do? It has pairs. It says that worker number one has 4 tasks. Some of them, shit, okay, not just one, but some of them will be done. Fuck, okay, yes, yes, not just, okay, yes, shit, okay. This is the mistake. This is the mistake. Here I am reducing x only by 1, but that is not the correct thing. I have to reduce x more amount than just 1. And how much more? As much as I can, or should there be a strategy? Like if there are 4 tasks in which worker number 1 is efficient, and there are 4 tasks in which worker number 2 is efficient, and let's say I have 6 other workers. So worker 1 and worker 2 would do one of their efficient tasks, and 3 will be remaining in this, 3 will be remaining in this. So this is not a good example. Let's say I have 2 workers, or I have 3 extra workers who do not have any efficient tasks to do. So whom do I assign these to? this three, or let's say this one has five efficient tasks and six in total, and he is doing one of them right now in this particular second. And I have to choose, split these three non-efficient task workers into three of these tasks and five of these. So should there, I think I can just subtract this from anything. It wouldn't matter. Wait, if I see the biggest one and I say all three of them are doing some task from this worker, then in the next pass, this worker, since he completed one of these tasks, and among the five that were remaining, three will be done by other people. Then he has two tasks, and this worker, number two, would have three tasks remaining. And I do not have any people who are in the middle of doing their tasks. Right. He can just do this, and this guy can also do this. And in the next pass, this one would have one task, and this one would have two tasks, and I would have three people remaining who are not doing anything. And this one would do this task, this would do this task, and I would have one task remaining, which would be done by this guy, one of these guys. I guess I can just arbitrarily subtract from any of these workers' tasks, and it should not matter. Maybe a little bit more dramatic difference in the number of tasks would be good. One, if one worker has five tasks and the other has just two, and I have four workers remaining. So I would have four tasks. Who This guy is not doing. This is doing one task, and this guy is also doing just one task and one. And I need to assign. Let's say one of them chooses this, and the three of them, three remaining people do this. Okay, simulation is not a good way. Simulation is not a good way. This shouldn't actually matter. I think this shouldn't actually matter because assigning one of these efficient tasks, which could be done by a worker efficiently in the next place, at the end of the next second, is same as assigning a inefficient worker to that task, because starting from now, he would also do it at the end of the same second that this guy would do it. So I think it should not be a problem, and I can subtract whatever I want. So I had M and E people who were in the middle of completing their tasks. So M and E, M and E, M and E. If X greater than M and E, then X minus equals M and E. And M and E equals 0. No, no, shit. Okay, I guess, okay. Number of people who, okay, I also need the updated value of M and E and the original value of M and E, O for original. So here I can say MNE O equals MNE. These are very abstract terms, and MNE O. Else, if MNE is greater, or even if it is equal, just do this. Else, if x is greater, if mne is greater, then mneo minus equals x and x equals 0. Yeah. Hmm? Hmm. It does work. Shit. Time is incrementing, and in every task, in every pass, I have m, the number of tasks which are remaining. They will be done by the number of people who can do some efficient tasks in this current chunk of time. And I think I have this up. Yes, I can remove this. That is cool. And MNEO, MNE original. And I then update the value of MNE to be equal to the number of people who are not doing anything right now. That is cool. And then I go through this. Right. And I keep update, keep reducing, not just +1, -1. Yes, number of tasks -1 because the guy who is efficient in this would have done something, and the number of and the people who were in the middle of doing something would also do something. Huh, this seems correct. This actually seems correct. If x is greater, if MNE is greater, okay, okay, this seems actually correct. This actually seems correct. Maybe not. Maybe not. Okay. Okay, it has been 15 minutes, 58 minutes. I think I can look at the solution now. I do not have to im I do not have to invent algorithms. Okay, now it says wrong answer. Uh, on which part? Actually, 88. Expected 4 found 3. Maybe is there something wrong with my logic? T plus plus. Mm-hmm. Yes, and MP size. That is absolutely correct. That is also absolutely correct. M minus MNE 0, the number of people who were in the middle of their tasks. And yes, that is the number that will be reduced. That is the same number that will be reduced from the counting also. And wait, here I got the wrong answer on test 200 something, 398. And where did I got the wrong answer on this? On 398. Wait, shit. Even though I added this bit, it didn't do anything. Okay, shit, because there might be tasks in which no one is. No, no, this is cool. 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 Because if I sum up all the values of m, then and yeah, yep, yep, yep. This should be working. And let's look at the tutorial now. It has been long. We can look at the tutorial now. It's been more than 1 hour. Blood test. Blood test is a cool person. Edit. Uh, educational rounds. Educational rounds are pretty cool. C. Schedule management. The statement should instantly scream binary search at you. Binary search. Binary search. This should scream binary search at me. Should because monotonous function. The function of t which returns the number of tasks which are remaining is always is non-ascending. It is always decreasing. It is always decreasing, either remaining the same or decreasing. So if given a certain t, if I can figure out how many tasks would remain at that given t, I should be able to do this. How can I do that? Binary search. So even if I have to go through all the tasks for every time, it should not be bad. For every call of the function, it should not be bad because I will only make log n call, and log n into m is not really bad, and t won't be actually really high. Minimum value for t would be 0 and the maximum value would be m. M should be the maximum because m or 2m. 2m. Yeah, 2m. We'll say 2m. 2m. Value of t won't be greater than 2m. Like never. Nope. It won't be greater than 2m. It cannot be greater than 2m because even if I it can be because it can be so yeah, it cannot be. Let's say I have just one worker and there are 10 to the power 5 tasks, and yeah, in that case this worker would be efficient in all of them, and it would take him 10 to the power 5 time to do this. So yeah, it cannot be greater than 2m. The highest value of t cannot be greater than 2m, and at minimum t will be 0 and at maximum t will be 2m, and 2m m is at max 2 and 2e5. M at max is 2e5. So maximum value for t max, not t-rex, t max would be 8e5. Yes. And how do I write a function which takes in a t and returns me the number of tasks remaining? It says binary search. So somehow I have to write this function because this function, let's say if t is like this and t goes like this, then this function is like this. And I am looking for this point where it becomes 0 because after that it is always 0, 0, 0, and at this point it is 0 for the first time. And here there are some values for it. Wait, shit. Yeah. Here after this point it is always 0, and here there are some values, positive values. So how do I find a way to calculate this function? Shit. I haven't even done a single question. Okay, that is crazy. How do I find a way to calculate this function? I cannot think of anything. Maybe if I give it more time, but it has already been 1 hour. So let's see. Clearly, if you can assign the workers in such a way that tasks are completed by time t, you can complete them all in t plus 1 or more as well. Yes. How to check if tasks are completed by some time t? What that means is that all workers have t hours to work on some tasks. If tasks took 2 hours to complete, then each of them could complete t by 2 of them. Thus, together they would be able to do t by 2 into n tasks if it took 2 hours to complete them. Okay. Now, how to incorporate 1 hour tasks? Well, we can redistribute the tasks in such a way that each worker first completes the tasks that they are proficient in, then some other tasks if they have more time. Yes, that makes sense. That actually makes s- sense. That okay, okay. Delete the whole thing. N M C N N M and a map int MP int C for int I equals 0, I less than n, I plus plus taken to C and MP C plus plus. Okay, and L minimum would be 0 and R would be 2m. It won't be greater than that. And L represents a way where the value is always non-zero, and R represents the T where the value is always 0. And while L lower than R, if at some point L becomes equal to R, then I'm out of things. R would be the answer because R always has 0 value. Int M equals 0. L plus R minus L divided by 2. And now calculate the value for this. And sum equals 0. for auto I comma x in map if the number of tasks that this guy can do x, if it is greater than m, the time that he has, then cmp equals cmp plus equals m. Else, or even if it is equal. As if there is more times. Yes, else if there, wait, this would always be done. Uh, no, this would only be done here. And here cmp plus equals, I have more time, I will do all of my tasks, and then cmp, I will do half of the remaining time tasks, which is m minus x divided by 2. Cool. And cmp plus equals the number of tasks n minus mp dot size divided by 2. Yep. Now number of tasks completed. If completed is greater than or equal to m, I did all of my tasks. Then r equals m. Okay, I messed up. I messed up a little bit. M is the number of tasks. So let's call this thing T. Yes. Yeah, T. Else, if I was not able to do, then L equals M. And am I always reducing this? R minus L greater than 1. Answer would be L plus 1. Hopefully. 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 Answer would be L minus L plus 1. Hopefully. 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 Because L is always pointing to the time where I was unable to do all the tasks, and R is always pointing to the time where I was able to do all the tasks. By the way, 6 is actually crazy. 6 is crazy. Six is crazy. Why would I say 6? Dot slash out. I have only one thing, one n. M is also 1. Task is also 1. Answer is also 1. Wait, am I doing the same old? A man never changes. One correct. And here I'm saying 5 and 5 for both of them. 5 and 5. Here I would go for 8. And why did L become 4? Why was L equal to 4? 4. Uh-huh. Uh, complete for first. Let's test. Only one test case, which has n equals 2, m equals 4, 1, 2, 1, 2 are the things. And completed was 6. So R became equal to m, that is 4 in that case. Then the middle point would have been 2, in which case R should have become 2. Okay, let's also see L and R with this. L, L and space R, R, and some space here. Okay, 1, 2, 4, 1, 2, 1, 2. Why do I say 5 here? Because I'm stupid, of course. That is why. Okay, okay. This is either L is correct or L plus 1 is correct. Or I can write a function. I can write a function for this whole thing. Which will take in a number and tasks done. It will take a map of integers. Let's call it MP and an integer time. And at the end, return T, return CMP. And okay, cool. Therefore, here and CMP. Okay, this line also has to go there. I need n also, the total number of workers. Make this a reference so that it is cool, and CMP equals tasks run MP at this time with this many workers. Outside CMP equals tasks run MP at time L plus 1 with this many workers. So either the answer is L plus 1 or L. Now, if CMP greater than equal to M, question mark, if that is, then L plus 1, otherwise L. Shit, I was expecting this to work. No, L plus 1 is the correct answer. L plus 1 is the correct answer. L plus 1 is the correct answer. Mm-hmm. Yep, L plus 1 should be the correct answer. CMP, CMP, and L. Maybe I should move on to some other question. It has been more than 1 hour on a single question. One, two, four, one, two, one, two. L was equal to 1. So yes, L plus 1 is L plus 1 is the correct answer. Let's try this for the second test case. I have just one test case where the values, okay, 1 hour 23 minutes. That is cool. Are you comfortable in 1300 rated problems? I, yeah, I think I am. I think I am. I think I can say that. I have done the 1300 problems here and this many, but I will have to go through them again. Yep, at some point I will have to go through them again. This one, this one, this one is quite, I don't know if the framework with which I'm thinking about this question, I think that is wrong because in that framework, this is quite complicated. Hmm. And divisible pairs, I forgot which one this is. Shit, I don't know why I have been unable to do this one. See, time limit exceeded. Maybe if I just implement this correctly, I would be able to do this also. And for me, I am not especially focusing on the rating of the problems. Right now, for me, main focus is to get to understand topics. For example, right now I am learning about dynamic programming. And for that, I have a few references. This book, Dynamic Programming, and today, for me of the stream, my target is to get to complete dynamic programming section. I've done rod cutting example, and in rod cutting section, they said that you can create a graph called a subproblem directed acyclic graph to represent a dynamic programming approach in which you can convert something like this, a recursive graph. into something like this, which is a DAG. What is a DAG? Directed acyclic graph. And yeah, this book is actually pretty good, cool, and you can go and find it online for free. Yep. And a graph like this is called subproblem graph, which can help you. But this was unable to help me yesterday. And yesterday is question number 3. So there is a lot of work that needs to be done. And there is bottom-up approach in dynamic programming, and top-down bottom-up approach uses iteration with tabulation, and top-down approach uses recursion with memoization. And yeah, that is all I know. I have to do some more work. There is this other problem that they have stated of parenthesizing a matrix, so that you have to do minimum number of scalar multiplications. Yep, minimum number of scalar multiplications, because yeah, they just said that if you have 3 matrices A1, A2 and AC, and if you multiply A2 and AC first and then you multiply A1, then you might get total number of scalar multiplications 25,000. But if you were to do A1 into A2 and then multiply AC, then maybe the total number of scalar multiplications that you did could have been 7,500, which is much better than 75,000. That is like a factor of 10. And yeah, I have to get to read this. Please tell how to do yesterday. E, I could only do till D. Bro, I was unable to do C. My bad, I was unable to do C. And D, I couldn't even figure out how to do D. I read the problem statement for D, and my idea was something like this. And you have a lot of points, right? You have a lot of points, and maybe you start somewhere. Let's say you start from here and you go to the right 10 to the power 9, and then you do this again, you go right 10 to the power 9, and then you do this again and you go right 10 to the power 9 times. And at this point, you know whatever distance you are getting is from one of these points which are at this end, which are the rightmost points, and then you go up the same amount, and you have used at this 3 into 10 to the power 9. You have used your 6 moves, and then you know exactly with which point you are getting the distance. It would be the rightmost and the topmost point, somewhere here, and you would be somewhere here, and the distance you are getting is something like this. And I don't know what to do after this. Maybe this like this is how far I was able to think. And actually, I would like to turn on the air conditioner. It is getting a bit hot. This 1 hour and 30 minutes. Maybe I should move on to the next question and add this one into review. Okay, this was 1300. 1400. 2 power sort. Okay, this is what we will do now. And maybe stop this. Yep. Shit. So the approach was right. Okay. Only 2 operations required like that. And okay, so at least okay. I guess the approach was right in that sense. Because I thought if I am at the like leftmost position right here with my coordinates -9 and -9, hmm, then I would be here at the top right. Yeah, shit. Okay, yeah. 2 is enough. 2 is enough. 2 10 to the power 9 is enough. And then I know I'm getting a distance like this, x and y, and I know how much distance I traveled from my initial position. How do I figure out these x and y? That is the main thing after this. And two operations for y. Okay, now you will get x plus y equal to d. This is equation 1. Okay, shit, I'm get okay, now figure out a way to get yes after whatever distance I'm getting. Okay, x plus y equals d. Uh, d. This is what I have, d1. And now figure out a way to get x minus y equals d2, and let's you can do yourself. X minus y, x minus y, x minus to get x minus y, I would have to get to this point by moving exactly y, and then get to this point by moving exactly y. Or maybe I can maybe okay, let's say my initial position was this is the top rightmost point, and this is the top bottom rightmost point, and I moved somewhere here. Now here I got here I had x and y, and I have x plus y equals d1, and I know this distance. This distance I know. Let's call this a. Okay, okay, and then I moved down, down, down. Right, I used, let's say, two of my moves, one to cancel the, no, four. I would have to do four. Yeah, one to get back to this initial y coordinate, and then two more to go out of range here. At this point, I have used eight of my moves. Okay, two like this, and then back, and then here. One, two, three, four, five, six, seven, eight. Okay, and now I am at some point here, and I know this, and I'm getting x exactly. This would not be exact if, yeah, if there are some at other point. Let's say this one is a bit to the left. Then I would know this x dash distance and plus x, and let's call this y dash, and I will get x dash plus x plus y dash equals d2, and I know this a distance, and I know this total distance. So y plus a plus y dash equals something that I know, and that does not, yeah, maybe I would be able to figure out. You see why we got x plus y, right? Because it was infinity plus x minus px plus infinity plus y minus py. Okay, point x and point y, and infinity plus x. X is my initial position. X is my current position. If x is one of our given points, try simplifying this equation. infinity plus x. X is, let's say, our initial point. Then I went along infinity to the right. Yes, yes, xy, that is x dash, we can call it. Infinity plus x minus px, we can call it, and infinity, by infinity you mean 2e9, and then infinity, we went infinity in the y direction, then subtract py, and you get d. Yes. Can you tell me, this would be very helpful. Can you tell me how you were able to get some intuition about problem C? It would be really helpful. This is graph, and after the stream, okay, I will do this. I will also do this after the stream. I can put this and some review. This is good. This one is good. Can you tell me how you were able to get some intuition for solving question number C? It would be really helpful. I mean, I know it is very hard to type in chat, but it would be really helpful. And thank you in advance. Here. Even though I read the tutorial for C and I did it, it seemed hard at that time. Now this one, D for the champion. Interactive problem. Let me just turn on the AC. Yeah, fine. Me back. Hello. Yeah. See, try thinking of what is most optimal at point I. Yes. The thing that I got confused in was this. I was thinking that if you have something like 3, 2, 2, 3, then at this point, the most optimal would be 0, here, 0, here, most optimal would be 2, this thing, and here it would be again 2, and then here it would be 3. But then here, if I were to pair this, I would say 3, but how do I know that this is 2? And that would be to look at the most optimal here, and I would get 3 plus 2 equal to 5. So yeah, maybe it is just I have to gain more experience in this and what can be the best cases. If I do choose this, first of all, given this number, I have to see, can I make a substring of this? Do I have had enough of this? If I have had enough, then I will see what is the mm, closest appearance of this number with which I can make a subgroup. So I would choose this subsequence to make a block of 3. And if that is the case, then yeah, then I should have looked at what would be the best subsequence at this index before this, which is 2. And now, since I'm making a block of 3, I would add 3 to my thing, 3 plus this, 2 plus 3 if I do choose this. And if I don't, then just 3. And the maximum is 3 plus 2 plus 3. So 5. 5 would be the answer here. Yeah, I guess it is just experience. Yes. So two cases, right? Yep. Either pick up the block as possible or not take it. Yes. And if it is possible, then I will see. I will check is taking it is better or just reverting to the last index is better and take the maximum value. And this is what I wrote. No, this thing. And maybe what I'm thinking is I have this vector of numbers and indi stores all the appearances of I that I have seen till this point. And here I'm checking if I have seen ai, the current number that I'm at, the size of this vector, if it is greater than ai minus 1. That is, if I'm seeing a 3, if I'm seeing a 3, if I'm seeing a 3, then I want at least two appearances of 3 till this point, and that is what I'm checking, 3 minus 1. If the size is greater than equal to this thing, then find this index I'm calling x. Yeah, I guess you do get what I'm trying to say here. Either pick up the block at I if it is possible or not take it. And if it is possible, then see would it be cool to take it. And if not cool, then do not take it. That is good. And it's been 1 hour and 47 minutes. And I haven't been able to solve even a single question, which is bad. Stopwatch. And we would move on to the next question. And I guess we can move on to the next question. The intuition for question number C was hard to get. But yeah, it is fine. It is fine. With time, I will get to see these things. And I think I can begin. Let's see. Given an array A of length n and an integer k, find the number of indices I, k, cannot take till 10. Sliding window, a similar problem was there in the second last contest, such that the subarray this I plus k, with the length k plus 1, with the length k plus 1, not with the length k plus 1 has the following property. Okay, if you multiply the first element by 2 power 0, that is 1. The second by this, multiply, shifting. Okay, if I shift it by 0 amount, shift by the second element by 1 amount, and shift the k plus 1th element by k amount, then this subarray is sorted in strictly increasing order. More formally, count the number of indices I, for which this would be true. Strictly. Hmm. Yep, that is very, very doable. Yes. K, right? K. And yeah, okay. The longest sequence. Okay, shit, this is the wrong session. This is the correct one. Should your PFP changed? So if you pick it, only need AI size blocks, and so only storing index up till size is necessary and sufficient. Oh, makes sense. Makes sense. Yeah, yeah, makes sense. Makes sense. Makes sense. So I can always pick up the zeroth index. Yeah, makes sense. Ah, it is not working. It's not Python. Not Python. Python is bad. Boilerplate 10 int n k, and this is fine. This is kind of fine. And count equals 0 and mx count equals 0, I equals 1, I less than n, I plus plus, and if ai in left shifted y1, if it is greater than ai, if it is greater than ai, then cool. And also some implementation. Length, TNT should display the length, and k can even be equal to 1. So k plus 1. 1 is always, I can always take 1. Right, if it is greater, then update this, and mx cnt equals maximum of mx cnt or cnt. Else, if that is not the case, cnt equals 1. And now, if mx cnt greater than or equal to k plus 1, let's test this. 2. Answer here is 2. And k is 2. If I multiply this by 2, it will be greater than this. So 2. And if I multiply this by 2, it will be greater than this. That is cool. If I multiply this by 2, that will I cannot go. Yeah. Yeah. I should not go till the end. Should go to the end till the end. Okay. 3 is greater than equal to 4. C out. Minimum. Not minimum. Maximum. Okay. Shit. I was not expecting that. Your answer is, why do I say 6? 3. 3 is the maximum here. 3 and 3. Yes. So answer should have been 0. Oh. Clang, not this one. And now we are doing the next one. G2. Yes. And nope. I bro going back to grinding chess now. Shit. Shit. Bro is a real giga chad. Bro is now doing chess. And this is the thing. Fuck. Shit. Okay. Just this once. Here I'm saying 2. The third last. Here. Here the thing is correct. Yep. Here, if I multiply this by 2, I'll get 24. So length is 2. If I multiply this by 2, then it will be, of course, greater. But here the thing. Okay. I don't need to. Response equals 0 and response plus equals maximum of 0, comma, C and T minus K. And also do this at the end. Okay, it works. The start as we are going. Yes, cool. It will work. It will work. And if I get this right in just 12 minutes, it will be really cool. It would be actually cool. Yeah. See, okay. I am not that stupid. I guess I can sometime do questions. 12 minutes. Yo, let's call it 13. 13. Okay. Okay. Whenever I see defeat, I do not have to beat myself with the hammer. Just persistence. Okay. Here, let me predict the tags, even though I did saw them. Okay. Here the thing is constructive algorithm. I didn't see that there. Constructive algorithm. I'm predicting what the tags of this problem are going to be. Constructive algorithm. And what am I using? Maths and binary search. Binary, not search, but binary logic. Iteration, iteration, binary logic, maths. Okay, sorting. I don't know why you would use, or DP. I don't know why you would use DP here. Let's see tutorial for G in division 4. Okay, G in division 4. That is good. What do we have? Note is the same as this. Yes, since we can divide by 2 power x, this means that we only need to check whether this is true for each adjacent pair of elements. Yes, let's consider as an example this. Okay, shit. These tutorials are really beautiful. I guess it is because these are in division 4. They are even giving a example. If this was division 2, they would have just like written only this much. They wouldn't have written this or even an example. Giving an example is too much. So let's see a new array B. Okay, they are now creating a array B. If B, where B equals 1, if this thing, and B equals 0 otherwise, then we know the whole chain of inequalities holds if all values in a subarray of length k in B have all their values equal to 1. Shit. Okay, yeah, that is cool. That is cool. It is the same thing that we are doing. We can reset the timer and go to the next question. Weird sum. Two hours and one question down. Let's go. Igor has a table of size nm with lines numbered from 1 to n and columns numbered rows numbered from 1 to n and columns 1 to m. Each cell has a color that can be presented as an integer from 1 to 10 power 5. Let us denote the cell that lies in this intersection of ith row and cth column as RC. Okay, we define Manhattan distance between two cells as the length of the shortest path between them. Yes. And then where each consecutive cell in the past must have a common side. Yep. Igor decides to calculate the sum of Manhattan distances between each pair of cells. Between each pair of cells with the same color, help him calculate this sum. Okay, this has n and m, and each of the next n lines describe a row of table. If I go n into m, n into m is the total number of cells, and that is 10 power 5. This would be n square Yeah, cool. Yep. Yep. Yeah, that is cool. That is cool. We can do this. And M and then the thing. Okay. Okay, why am I getting Python before the other thing? N M CNN and N, and then a of map of integer to pair. Inti Shit, this is a bit complicated. A map of integer represents the color to a vector of pairs. And can it be even better than this? No, I don't think so. Let's call it MP. For int I equals 0, I less than n, and I plus plus, and for int j equals 0, j less than m, and j plus plus. What we do is int c, c in c, and if mp dot count c, if c is there, then we will iterate through all the things there, all the pairs. For auto x comma y in mp bracket c, yes, sm plus equals plus equals absolute value of x minus I plus absolute value of y minus j, and then no matter what it was, mp bracket c dot push back this current pair I comma j, and then at the end c out sm. That seems right. That seems right. Hmm. Okay. Okay. Seems to be right. Shit, 5 minutes. This was pretty easy. Time limit exceed. Let's before submitting hypothesize. Will my solution get a time limit exceeded error? What would be the worst case? The worst case would be when all of them belong to the same point. Yeah, all the colors, all the things belong to the same color. Yeah, that would be worst. So what I would like to do that would lead to n square time complexity is it? Yeah, I think that should be fine. That should be fine because I have 2 seconds. It is running. Maybe time limit exceeded. Yeah, time limit. Okay. We have to make this more efficient than this. So what we have to figure out is when I have a bunch of x and y's, x1, y1 and x2, y2 and x3 and y3, and are there any other limitations? Maybe something I might have explained. I was AFK for 2 minutes and you now with another task. Did you finish the last one? Yes, I did this one. Too short. This was quick. This was actually quick because even spending 1.5 hours on this question number 12, I was unable to do this, but I only spent 13 minutes on two sort and I did it. So okay, that is cool. And now with this, we only have to optimize this. We are only getting TLE error. All we have to do is optimize. Maybe since I know this fact, since I know this fact, maybe instead of a map, I could opt to use a vector. No, no. The main bottleneck is not that. The main bottleneck is whenever I see a color, I am making it square with everything else. So what I need is I have a bunch of these pairs and I need to find the distance between them and add them. Okay. Okay. Which let's say I have a bunch of numbers x1, x2, x3, x4, dot, and I need to find x2 minus x1, x2 minus x3, x2 minus x4, and then x2 minus x3, x2 minus x4, and x3 minus x4, and add all of this up. Let's say we only have this much, yeah, and let's write something. So what I need is, and let's say they are in ascending order, x4 minus x1 plus x3 minus x1 plus x2, yes, x2 minus x1 plus x4 minus x3 plus x4 minus x2 and plus finally x3 minus x2. And now can we simplify x1, x1, x1? Okay, let's say minus 3 x1 is what we have, minus 3 x1 here, x1 here, x1 here, and for x2 I have x2 once here, once in shit. I have done a similar question. Shit, I should have known. I have done a similar question before. Shit, yes. What I essentially want to find out is this summation I changing from 1 to n and j changing from 1 to n and absolute value of xi minus xj. Yeah. Yes. Is that what I want to find? Yes, that is what I want to find. And do this with x and do the same thing with y. I equals 1 and till n summation j equals 1 till n, not x, this should be y. Y I minus y j, even though this one looks like j, this is I. And yeah, that would be answer for one color, and do this for every color. Okay, and I should have known this because Why should have why I should have known this? Because let me show you. We go to my channel and to posts. See, I'm live. Shit. Uh, then here I did post about this. Mm, it was a while ago. Yeah, motivation. This thing. See, see, two summations, and I'm updating these two, and there is a modulus function around them. Two summations. These two are changing, and I have a modulus around them. Yep, the same thing. Shit. And I can do this thing. Yep. Okay, let's do that. It will need some post processing. Very cool. Taken and just push back, and I can actually write a function which will return. It will be called this, and it will take in my map, which is no, it will not take in my map. It will take in a vector of pairs of integers. Let's call it V, a reference to that thing. And yeah, long this initially 0 and again return this. And here what I have to do is for auto reference x in MP sm plus equals this on x. Dist on x dot second. The particular value of the color does not matter, only where it appears. And here I have to do my function calling. So first of all, I have to sort this thing, which will reduce the time complexity from n square to log n. So sort, maybe pair of instead of a vector of a pair of vectors. No, it is fine. It's fine. V dot begin and V dot end. First, we will find the answer for x. We'll find the summation for all the x. We also need a prefix. And instead of creating a prefix every time, what we can do is use a universal prefix. Vector of integers pref and the size cons n equals 1e5. 1e5 is cool. 1e5 is cool. Cons int n. Even though this doesn't have to be const, but anyways, it looks cool. And now I will iterate I less than v dot size and I plus plus prefix. So pref I equal I plus 1 equals pref I plus the last one plus the current value, which is vi dot first, because right now we are just doing this for x to calculate the sum of x. And now we will do this. We will do this again. for int I equals 0. Yeah, equals 0, I less than v dot size and I plus plus rest plus equals how many? Yes, yes, x would be v dot size into vi dot first and rest plus equals pref n, where, okay, let's call n equals to int n equals to the size. And look at this. In Vim, we can say now substitute wherever you see v dot size with n. See, that is full with n. Add prefix of, make prefix not integer but long. And minus prefix. No, yes, shit. Yes, my bad. Shit. A better representation would be rest plus equals ref n minus n minus I into v I dot first. Ref n, yep, the sum of the whole thing minus till this point multiply by I minus n. Is I minus n correct? Yes, yes. N minus I. Yes, n minus. Absolutely correct. Yes, absolutely correct. Yep. No, absolutely wrong. I plus 1, I think minus 1. Yes, yes. So the place that I am at, its sum would also be reduced. And yes, this is also fine. And now, Cool, 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 cool. That should give me the Manhattan distance for x. Now sort again with a custom sort function and auto A, auto B, and return A dot second smaller than B dot second. And copy paste. DRY. Do not repeat yourself. Okay. Okay. Cool. I think that is cool. I think that is very, very cool. If it works, why is it returning zero all the time? Shit. Why does it say zero every time? That is horrible. That is horrible. Mhm. A pair of vectors would actually be cool. Would actually have been cool. Can I do created a pair of vectors? I think I can. I can. I can. Yeah. MP x and map integer to vector of integer mpy. C dot pushback mpx x and mpy c dot pushback j. And here a generic function would do the job. This will take in a vector of integers, a reference to it, and we will call it a v and long in rest initially 0 and n equals v dot size, and at the end we will return resolution answer. And here we can say for auto color and v in mpx sm plus equals call our dist function on this v, and then sm plus equals call the list function in mpx mpy c and then return the sum. Now we have to simply implement this sort v dot begin and v dot. I already have the prefix. So for int I equals 0, I less than n I plus plus. Ref I plus 1 equals prefix of I plus vi. And now for int I equals 0, I less than n and I plus plus sm res plus equals the next ref n minus ref I minus n n minus I into n minus I into vi. N minus I is the number of occurrences and n is 1 indexed and I is 0 indexed. So I would also be included. That is plus equals ref I minus I into vi minus ref I. Okay. Okay, it is twice. Okay, why is it coming out to be twice? Why is it coming out to be twice? Everything else is fine. It is just twice. Yo, hello. I don't know what you are doing. Okay, we are doing some competitive programming practice, but I'm planning to learn Python. That is cool. Well, not the planning part, but actually doing part, but planning is also cool. And if you are looking for something from where you can learn Python, then I would say you can go to this place. Okay, CS50, you can take this course. CS50 is Introduction to Python Programming, and this is by Harvard University, and it is free. That is pretty cool. And take that, which is pretty cool. And now here, this function, we are trying to implement this thing, summation of summation when you have modulus around like this. Okay, but my answer is coming out to be twice than the value, than the actual value. Why is that? I can simply do sum minus sum divided by 2 and output that, but that does not fix the problem. Why is this wrong? N is correct. N is correct. N is correct. And I have to sum x and y both. Yes, I have to sum x and y both. That is also correct. So maybe something is wrong with this, or not just maybe. I think definitely something is wrong with this thing. Sort the whole thing. Yes, absolutely correct. Cannot be bad. Find the prefix. Absolutely correct. Absolutely correct. And then for int I equals 0, I less than n, I plus plus, add to res. Summation of all the things that are to the right, prefix n minus prefix I minus, yes, this is correct, this is correct, this is correct, this is correct, this is correct. Yes, and this is also correct. I into vi, this is correct. I is the number of I is the number from which the other numbers till now are greater than. Mhm. Yes, yes. And pref I is the sum of the numbers till ith index except the ith index up till I index. And I is the number of those numbers and vi, and subtract from vi this thing. If I do minus 2, even though this is very bad, let's see. Okay, let's check the time complexity. If it fits, I think it will fit. It will fit. We should not get any TLE errors. It should fit. Yep. Just that course would be really good. CS50, Python would be really good. Wrong answer would not be really good. Wait, if this is some overflow error, it is some overflow, even though this is big. This is long, long. Wait, and do they say that I have to take modulus? Yeah, the advice would be this. Uh, Take Introduction to Programming with Python by CS50, Harvard, and just do the projects. Projects are hard. That is the point. I'm getting a signed integer overflow error. Integer overflow error. Integer overflow error. Help him calculate this sum. They are not saying it can be really big, but I will take the modulus anyway. Constant m equals 1 e9 plus 7. Take the modulus with this thing. Rest modulus. SM modulus m. Why am I getting integer overflow? I shouldn't be getting any integer overflow. Wrong answer is crazy. Is it because of integer overflow? Yeah, yeah, it is because of that. It is because I took modulus. Pref is long long. How is it? How is it this big? Answer is this. Okay, this is a very big number. Shit, 10 power 19. 1, 2, 3. 1, 2, 3. Alas, this is within the limit. This is absolutely within the limit. Signed integer. Wait, is it because I and everything else is integer? Okay, yes, I can make this long long, and can I shouldn't have to do this. This is bad. This doesn't seem right. Feels like there should be no need for doing this. Anyways, let's check if it works. Okay. Shit, that was the thing. That seems to be the thing. Mm-hmm. Shit, there are so many test cases in this one. 40 minutes for this. Okay, cool. And what did we learn? What did we learn from this? Um, we learned a way through which we can take summation like this. I mean, I already knew this, but the fact that I was, yeah, this was cool. This was cool. This was not very hard. This was cool. Only the implementation took time and connecting the dots took time, but now it is cool. Now it is cool. Let's see. Let me predict the tags. The tags are going to be prefix. If prefix is a tag prefix, I would see prefix, and I would see sorting prefix. Yeah, sorting and prefix are the two things that I should see. Sorting and prefix is not there. Yeah, geometry, maths, data structures, combinatorics. Okay, and now I would like to do a crazy thing, and that is remove this whole thing and now write the whole thing from scratch. Because if I am saying that I have done this question, then I should be able to do this question again, right? Int n and m, and I will not even look at the problem statement now. Shit, what do I get next? Yes, I will now create a map integer. Integer represents the color to a vector of integers. Fine. And it will be called x and map integer representing a color vector int y. And now for int I equals 0, I less than n, I plus plus. Again, inside for int j equals 0, 0, j less than n, m j plus plus, and let's say int c, c in c, and mp not x bracket c dot pushback I and y bracket c dot pushback j. We have everything. Now we would need a function which returns a long. It will be called dist. Or what would I like to call this function? I would like to call this function abs sum double m absolute summation. Yep, of a vector. It will take in a vector of integers called v. A reference to it actually res equals 0, return this. Now sort v dot begin and v dot end and a prefix vector of long prefix of size 1e5 plus 1 and const int n equals 1e5 plus 1 capital N after this for int I equals 0, I less than n. What is n? We will define it above int n equals v dot size, and what do we have? Prefix of I equals no prefix of I plus 1 equal pref prefix prefix I plus vi, and then int I equals 0. We'll go through the loop again. I less than n, I plus plus, and yep, I plus plus, and what we'll have is res plus equals pref n minus pref I minus n minus I into vi, and we have to make some cautionary steps here so that this does not overflow. Pref I, no. Here we will have LLI into VI minus ref I. Yes, minus ref I. Yep, cool. And yeah, that is the whole function. That is the whole function. That is the whole function. And now for auto I comma v n, let's say x, what we will do is sm plus equals call the dist. No, it is not called the dist function. It is called abs sum with v. Yeah, just v, and summation plus equals abs sum for y bracket I, and somehow it is bad. Somehow it is bad. Shit. Okay, of course. LL sum equals 0. See out sum, and I would like to be a little cool here and do this instead. Does it work? Though, shit, yes, I forgot. I forgot. Somehow it is giving twice the answer that I need. Somehow. And this is correct. This is correct. This is correct if I go there and submit. But somehow it is returning twice than the actual value that I need, which is bad. Of course, it is bad. Cool. But why is it returning twice than the value that I need? Huh? Shit, yes. Of course. Yes, 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 yes. No, 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 no. Yes. No. If I do this, yes, I need unique pairs. I need unique pairs. If I do this, hey, I need unique pairs. Yeah, that was the thing. That was the thing. Now, now it will be correct again. Cool. And I would like to create a snippet of this thing. Res plus equals long I into vi minus ref I. And I would like to create a snippet of this thing. It is running. Okay, cool. Snippet from this to this, copy, and go here, CP, and abs sum dot cpp, paste, and globally substitute LL with long. Yeah, cool. That is cool. And snippets dot lua print vector. Nope, not print vector. It is abs sum and abs sum, and here abs sum, abs sum, abs sum, abs sum. Here also do the same thing. Yep. Uh, yeah, cool. Just change these and print function to calculate summation to calculate absolute summation for a vector and y inside. Did I yank? Yeah, cool. It does work. It does work, and I would be right back. I have to go to washroom. Yep, I'll be right back. Yep, I am back, and we'll try to do one more question, at least one more. We have only done two questions today. No, three, shit, including this one. Weird sum. Let's see, refresh. Rank is also updated. That is cool. Okay, we have shit. We have actually only done two questions. We were trying to do this first one, but we were unable to. Let's do some fortune telling, but before that, let's see the editorial for this. How it is supposed to be legitimately done. A, uh-huh. Shit, it is A in division. It just says code forces around this, but division 2. Okay, it was division 2. Game A. It is easy to see that if there are no what weird sum. A tutorial. Where is weird sum? Weird sum is A here. Okay. I guess it was division 1 and 2 combined, and this is for division 1. The problem number A. See, this is the thing I was saying. This is the thing. Two summations, two summations, two summations. We have to have two summations. Okay. We know that the Manhattan distance between this and this is equal to this thing. For each color, we will compose a list like this of this color, Compute the target sum for this color and sum of the answer for all the colors. The sum is equal to, yes, yes, which we can just simply split. Yep. And we have written a function for this, which we are calling on R and C one by one and finding our answer. We will compute the first sum. The second sum is analogous. Let us say S be equal to R. Let us say array S be equal to R, but sorted in increasing order. That is what we do. We sort and then we find the answer. This was cool. This was cool. Okay. I actually struggled with this. How does this thing work? But now I do get this. I went to Reddit and there was a guy who explained this thing to me, and I am very helpful to him. Or maybe that Could have been a woman, I don't know. So we iterate. Okay, how are they avoiding double counting? From I to this, and J goes from I to that point. And yes, okay, cool. Okay, they are actually being smart about this. Okay. This thing equals this thing equals this thing. Uh, Shit. Okay. The value Sj occurs in the first color. Double sum. Exactly J times. The value minus Si occurs in the second sum. Exactly. Okay, how did the op how can they just open this thing? Okay, because it is sorted. Because S is sorted. S is sorted. S is sorted. Makes sense. S is sorted. S is sorted. Makes so much sense. Cool. Okay. Yeah, they are just doing the same thing with some different manner. That's cool. And yep, that is cool. And we can move on to the next question called fortune telling. Let's go. Start the stopwatch. Do some updates and with NeoM. I would like to build NeoVim from scratch. Not from scratch. Build in the sense git clone and then build. Uh, GitHub NeoVim. Go there. NeoVim. Yep. NeoVim is a project that seeks to aggressively refactor Vim. And we can, I guess, just copy this. Okay, it is 41% in Vim script, 30% in Lua, CMake, okay, 27% in C, Python, shell script, and other languages also are there. And there should be TJ DeVries, but he is not here somehow. Anyways, let's get back to our question. Alice and Bob are okay. Alice, yes, your friends Alice and Bob practice fortune telling. Fortune telling is performed as follows. There is a well-known array n, a of n non-negative integers indexed from 1 to n. The tally starts with some non-negative number d and performs one of the two operations for each of the numbers in increasing order of I. From the start to the finish. Possible operations are replace the current number, add di, or replace the current number with the XOR. Hereinafter, this denotes XOR. Notice that the chosen operation may be different for i's in different tallies. Okay, okay, but in one pass, do I only do this or this? Okay. D performs one of the following operations for each. Okay, do this for all or do this for all. Okay, notice that the chosen operation may be different for different i's and for different. Okay. One time Alice decided to start with D equals X and Bob with D equals X plus 3. Each of them performed fortune telling and got a particular number in the end. Notice, no, okay, their current number will be, okay. Each of them performed the fortune telling number of times and got a particular number in the end. Notice that the friends choose operations independently of each other. That is, they could apply different operations for the same I. You learned that either Bob or Alice ended up with number Y in the end, but you who, don't know who of the two it was. Given the numbers Alice and Bob start with and Y find out. Given the numbers Alice and Bob started with and the number Y, find out who Alice or Bob could get the number Y after performing the operations. It is guaranteed that on the jury test, exactly one of your friends would have actually gotten that number. Hacks, you cannot make hacks in this problem. Okay. N X, wait, why do I get N? N is, okay, I will also get an array. T, the first line of each test case contains three numbers, N, X, and Y. The length of array A, Alice's initial number, Bob's initial number is Alice plus 3 and the number one of your friends got in the end. Okay. Okay, if I do XOR twice with a number, that just cancels the whole thing. And yeah, what does XOR do? XOR might actually increase the number or might decrease the number. It depends. But I can add a particular number multiple number of times. That is cool. And how many tellies there are? Alice starts with this bomb. Each of them performed the fortune telling and got a number at the end. In one telly, in one go. They did this in one go. Fortunately, telling is performed as follows. Fortune telling. Okay, and okay. They ended up with 9. Alice by 7 plus 2, 9. And here Alice started with 0, Bob started with 3. How to get to 1? How to get to 2? In the second test case, Alice could get 2 using this operation. 0 plus 1, and then take its XOR with 3. Yes, 3 is 1 1 and 1. XOR of 1 1 with 1 is 2. That is cool. In the third test case, Bob started with this. Bob started with 3. Yes, with 3 and could get 1. He has to get 1. So he adds 1, 4, and then add 2. We have 6. Take XOR with 3, 6. 6 is 110, 110. XOR with 1 1 would be 101, which is 5, and 5 XOR 1, 5 is 101, and 4, yes, I would get 1. 101 XOR with 100 is 1 simply. Okay, so what I do not get is how many trials they get. How many times do they go through the array? The tally starts with some non-negative number D and performs one of the two operations I to N in the increasing order of I. Possible operations are either add this current number to your number or replace their current number D with, yes, denotes the bitwise or shit. It just takes 1 second. So this is something maths related. Why can be actually pretty big? Long it is going to be. It's guaranteed that the jury tests exactly one of your friends could have actually gotten that number. You learned that Alice or Bob ended up with this. Okay, let's try to do this. And we will do this. Define n, define int as long. Int n and x and y. C in n, x, y, and vi a size n for auto reference x a into x. I have the data now. What do I do with the data? I have the number with which I begin, and this is my target number. Yo, bro, please explain again the difference. Third question in yesterday contest. Ah, the third question in yesterday's contest was this thing. Delete this. This thing. Yep, it is dynamic programming. And what were we doing? Taking AI in and index. Yes. Now I remember. Yeah, so it is dynamic programming, and the again stop this for a minute. And the main idea is that if you have been given a bunch of numbers, let's say this is your sequence, and I am assuming that you understand the question. And yeah, let's say we have a sequence like this. Then for then you will have a vector. You will have a vector which will contain the best possible optimized answer for this current index. So when I am here and my array is just this single element, then I cannot make any blocks because because this is the only element that I have and I do not have three of these. So I cannot make a substring of this thing. Therefore, answer would be 0. And here I see for this number, I have a choice. Either I create a subarray, a substring of this number, or I do not. And here I cannot create a subarray of this string. So here also answer is equal to whatever the answer was on the last string, which is 0. And while I'm doing that, I also have another vector. Yep, these are indices in vector, and this is a matrix. When I was here, I was at index I equals 0, and here I saw can I create a block of this thing. I cannot because I do not have enough threes. So I went on and I added this 0 here. And then I was at index I equals 1, and here I checked can I create a substring which would be of which would where I would be using this. Do I have enough zeros? I do not. And do I have enough twos? I do not. So I move on and I put the index of this 2 here in the second vector. Then I go here and I see if I want to create a block which has 2, in which I would be adding this. If I want to use this, then I need at least one more 2 before this. And do I have one more 2 before this? Yes, I do, which is this one. And how do I know that? I see that by checking the size of this array. And I see that the size of this array is 1. And the number of 2's that I need is also 1, which is cool, greater than equal to my size that I need. So in this vector, I will see the index of the 2 with which I can create my answer. So here, if I were to create a substring that ends at this point and starts at this index, again, that ends at this index and starts at this index, then what the answer would be equal to this thing 2, because I will have a block of size 2 plus the best possible answer. Let's call this res, or we can call this dp, more conventional thing to do. We can call this dp of the index in this -1, which would be dp 0. And we see dp0 is 0, so our answer would be 2 plus 0, and we can put here 2. Then we go to this thing and we see I need 2 3's. Do I have 2 3's? No, I only have 1 3. So the best answer would be the answer for the last index, which is 2. So I just put here 2, and I add the index of this thing, and also I will add the index of this 2 into my 2 array. The index of this thing was 2, and now I will move on to this 3, and here I will also add this 3, that is 3. And when I am here at this 3, I will have to ask, do I have enough 3? I need 2 3's before this, and in my vector of 3's, I do have 2 3's. 1 3 is at index 0 and 1 3 is at index 3. Now I have a choice. If I do create, if I do create a substring which ends at this thing, then that substring would have to start at this index. So I have to find the maximum of, if I create a substring which ends here, it would result in 3 plus dp of this point. Let's call this index -1, and yeah, dp of -1, which is 0, comma, if this would be the case if I do choose this element, and if I do not choose this element, dp here would be same as dp in the last element. So dp and dp in the last element, since the index of this thing is 4, index of this thing is 3, so dp3, and this thing dp3 is 2, and this thing is 3. 3 is maximum, so we put here 3. And now we are here, and I ask myself, do I have enough 3's on the left? And before doing that, I will also add index 4 here. Now I will ask myself, do I have enough 3's on the left? I need 2 3's, and on my left, in my 3 vector, I have 3 3's, and 3 is greater than 2. So that is cool. We can choose these, but I only need 2 of these 3's, right? So I will choose the 3's that are closest to my current number, and those would be the upper side of this 3. So these 2 3's, and therefore I would start my subsequence from this index, which is 3. I will start my subsequence from here, and I would find the maximum of 3 plus dp. What was the best before this number? This is 3, so what was the best? Add 2 comma, dp of the previous one. The index of this thing is 5, so dp4, dp4. And as we see, answer of this thing, dp2 was 0, 1, 2. dp2 was 2. So this would be 3 plus 2, 5. And dp of 4 was 3. So 5 is maximum and 5 would be the answer here. That is cool. That is how you do this. And you just have to implement this. That is the thing. You will just have to implement this. And now on to this thing. And I hope I was clear. Maybe my explanation was not that good, but I guess this might give you some idea as to what I'm trying to say. Yeah, that is fine. That is fine. And now to this question. I can start my timer. And yep, what do? We can either add the current number or we can take XOR of the current number. I only have two choices. Dynamic programming. I might add mm, XOR. If I take the XOR of these two, nope. No. Order depends. It depends on the order. I literally have no idea for how I can solve this question. Yep, no idea at all. I'm adding a number and I'm taking XOR of some number. Adding a number and taking XOR of some number. Okay. And I do not just want to jump to the tutorial, but I can tell right now that I do not have any idea as to what I can do here. What I have is, let's go through this. Let's go through this and let's not beat ourselves up. Okay. My array is like this: A0, A2, right? A3, A4, that is what we have. And we have some X and we have some Y. Let's, before this, like good mathematicians, use some examples. Yep. So what does this mean? This means that I start with 0 and I want to get to 1, or no, if I can get to 1 or cannot. Shit, that would be actually cool. If I can get to 1, then Alice would win. If I cannot get to 1, then Bob would win. So that is cool. And I have numbers 1, 2, 3, 4, and given a number, I either add this number to my X or I take its XOR with X, with the result that I got after doing the operation on the last number. I take XOR or I add. But we cannot Brute force is bad. We cannot brute force. Maybe if I try to look at this in binary sense, because we are handling XOR. So 0, 1, 0, 1, that is XOR. And even if I add them, does not mean anything. If I take their difference, that is also 1. Okay, this is starting number X. Let's say I start with X and I want to get to Y. And I have just two numbers, A1 and A2. What are the possible values of Y? Let's say I added both the numbers X A1 plus A2, and that is one value for Y. Another would be when I added the first number but took XOR with the second number, that would be the second value for Y. And then when I took XOR with the first number and added the second number, that would be another value for Y. And when I took XOR with both of them, that is another value of Y. And XOR might increase the value or might decrease the value. Yep, XOR could increase the value, could also decrease the value. We cannot say for sure. But addition always increases the value. Addition always increases the value. XOR might increase or might decrease. No ideas. Wow, 1400. Yo, nowadays our knowledge is increasing very fast. Yo, no comments. Okay, but how do we do this? XOR. I can add XOR. Addition always increases the value, and XOR always decreases the value. No, XOR, we do not know whether XOR increases or decreases the value. You cannot be sure. But what we do know about XOR is that XOR has memory. XOR has memory. Memory. If I take X XOR Y and then take XOR of that thing with Y, I will get X. That is one thing we know. That is one property of XOR, the special, most special property of XOR. So what is the point? There is point. But what do we do? Any ideas? Any help would be appreciated. Addition increases, and for XOR, we are not sure. Like it is unpredictable. Is it unpredictable? Depends on zeros and ones. I mean, okay, this does not feel really good because when addition, I'm thinking in base 10, and when we are talking about XOR, we have to think in base 2. But there is some relation. Is there some relation in addition and XOR? Thinking of addition in base 2, I do not have much experience of addition in base 2. But Zor is cool. Zor is cool. Zor has memory. And let's go a little bit off the topic. Okay, no, not my passwords and everything. But in my bookmarks, there was a reading list. There was an article that I had on Zor, all bookmarks. Uh, 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 shit. There was some article. What is go by example? There was some article, and what is it? Article. There was an article that I had. Yeah, that's Zor trick. Shit. Here it is. This article about Zor. This whole thing is just on Zor, and it would be really cool. One day, I guess I will read this on a stream, and we will go through this together. Now, what is go by example? And we are going totally off the topic. Shit, this website looks cool. Go by example. Hello world. How to write hello world. Okay, shit, go by example. Okay, learn the Go programming language by example. Okay, okay. Go is open source. That is cool. Okay, I didn't know that. Official Go by example is an hands-on introduction to Go programming language using annotated examples. That is cool. Okay, if we want to learn Go, we can go there. Okay, that is cool. Yeah. And any help with this would be really nice. Okay, no help. No help. X plus A1, I could either add or take XOR, and there are possible for Y. If there are n numbers in the matrix, there are 2 power n possibilities, and n at max is 10 power 5. So we cannot brute force for sure. Brute force is not good. We have to do something else. We have to do something else, something better. In an increasing order, that seems to be important. And exactly once, that is cool, because if I see that Alice cannot reach the target number, then Bob must reach the target number, and I do not have to check for Bob. I just have to check for Alice. And looking at this, I can tell just add these two numbers and Alice will win. Alice will win. And here, here I cannot. And these examples are simple. Later, yeah, X can be very big, Y can be very, very big. Look at this, 10 power 15, borderline unattainable. Alice, Bob. And to just go off the topic a little bit more, the first time that Alice and Bob, that these names were used as an example, was in the RSA paper. Shit, Google said RSA, RFC. Okay, there is a RFC for that. Let's see. Alice. Shit, there is no Alice. Shit, there is no Alice here. Okay, so maybe not the RFC. Alice and Bob. Yep. And according to some research that I did, this is the first time that Alice and Bob, the names were used as an example for something. And when did this paper come out? Dates? Dates? No dates. Dates should have been here. But anyways, maybe at the end. Ooh, 1977. That is pretty old. 50 years ago. 48. Alice and Bob. Shit, 77. Ah, yeah, cool. What could even be the approach with which maybe I could get to something resembling the answer? What could be the approach which I could use here? What do I know? I know that I am starting with this number x. That I am starting with this number x, and I need to check, can I convert this x into this y? Convert this x into this y, and what are the operations I have? I have a bunch of numbers a1, a2, a3, dot dot till an, even though it looks like a 9, till an. The operations I could do is I could either any given number starting from left to right, I could either add that number or take XOR. And I do not want to brute force. Let's say I do not want to brute force. Brute force is bad. I mean this. Yep. mm, Complete search with the pruning. Okay, let's say I start iterating with I to this point, and I take my current x, whatever it is, and I add AI, and I take XOR with AI, and then I call the function, a function which then I recursively call the same function, which will start iterating from here, once with this value and once with this value. And nope, how would I know? Yeah, it will just, yeah, every function call fn makes two function calls, fn minus 1 and fn minus 1. And this is not like good, not just this, it makes, since there is a loop inside, it is going to make this many calls n times, and then the same goes for these functions. So 2n, yes, fn function makes two fn minus 1 calls, and then this is going to make these, since this many functions are going to make more calls, so I would have 4n minus 2 calls. So how many things do I have? Wait, 2 is bad, no, shit. n into n. Shit. 2 into n. And then this mean a single fn function will make fn minus 2 2n calls, and I have 2n of these. Shit. In total, 4n square calls. And then these will make 8n cube fn minus 3 calls. And let's say, apart from that, it just takes a constant time c to solve a single question apart from this. And the height of this thing is n, since we start with n and we are subtracting 1 1 every time. And at a given, let's say, row I, how many function calls there are? If I start I with 0 and 1 and 2, I have 2 power I n power I f into c. That is, yeah, that is how much constant factors there are. And multiply this thing by the height of this whole tree. So 2 power I, and I goes up till n. So 2 power n into n power n plus 1. That is going to be the time complexity if we go with that, n plus 1. So we do not want to go brute force. I am pretty much sure that this is somehow bad, and like this is somehow wrong, because the total possibilities that I have is 2n. The total possibilities that I have is 2n, 2 power n. Anyways, getting back to the question. Okay, how do we do this? Yes, I guess I can look at the tutorial. It is not that bad. I do not have to feel bad about looking at the tutorial. No one has to feel bad about looking at the tutorial. The main goal is to learn and not invent algorithms. And I am unable to come up with any ideas as to what I could do to reach a solution. And I do understand what is happening in the question, what is being asked, and I am out of ideas. Not that I'm out of ideas, I do not have any ideas to begin with. And Crazylin knows how to solve this. But can you figure out which of your friends cannot get the number y regardless of the other order of the operations? Cannot. The answer to the problem would be the other person, since the jury guarantees that exactly one of your. Can I know if a person cannot get to that point, huh? Regardless of the order of operations? How would I know that? Uh, Regardless of the order of operations, can I know if a person cannot get? Okay, so we do not care about the actual procedure. Of course, we do not care about the actual procedure. We just need to know if it is possible or not, given this starting number and the ending number. And regardless of the order, no, still does not help. Does not help. What do the numbers, this, and this, have in add? Shit. Shit. Okay. If I have, let's say, 57 and 49. Okay, let's represent these in binary. 57, what would it be? 1 for 32 and subtract 32, it would be 25. Then 16, yes, 16, 25, 9, 9, 8, 1, 0, 4, 2, 1. That is 57. And now 49. 49, 1, 32, 17, 17, 1, 16, and just 0, 0, 1. Okay. If I take XOR, I will get 0, 0, 0, 1, 0, 0. And if I add them, I will get 0, 1, 0, 1, 0, 0, 1, huh? No, 1, 1, 1, 0, 1, and 1, 1, 1, 1. Yes, this is what I will get. And is there something in common between the two? Not really. This bit is on in both because here we had 0, 1, but it was only on because there were no ones here. If there were ones here, I would get a 0 in both case. But here there were both ones, but I didn't get a 0 there. I got a 1 there instead. So that cannot be guaranteed. Shit. Nah, no idea. Don't know. What do all the numbers that can be obtained by all the combination of the operations start with have in? Okay, so there is some invariance that stays. There is some invariance that parity. No, parity changes here. Parity changes there. Yes, parity changes. And maybe they, yeah, I cannot definitely say. Even if the parity matches that, yes. So I need to find some better invariance than parity. The parity is same even if I add a number, but here in both the cases the last bit was 0. Something has to be reserved. The last bit was 1, and that is the only reason parity was same. Yes, parity. If this is my x and I had 1 here, now parity changed. But the parity in both of addition and subtraction is same. That is fine, but is that the thing? Parity is same, but is that the thing? No, it is not that powerful. Yep. Because parity being different would tell me, yes, this is not possible. But parity being same does not tell me, yes, this is possible. Right? Different parity, DP, indicates not possible. But same parity does not indicate possible. So it would only be helpful if their parity is different. If I find different parities at the end. Could I actually end up with the same parity? Here, if I had 1 at the end of my x, it would have reverted, it would have become 0. And if the other number was 0, it would have been same. And if I had 0 to begin with, at the end of my x, and the other number was also 0, I would have 0, and if the other number was 1, I would have 1. It's not really powerful, I would say, because here, in case of 1, when I start with 1, it does change. Sometimes it becomes 0, sometimes it becomes 1. So yeah, that is not the thing, I guess, that they are referring to as the invariant. Solve lead code, but think to spend time in CP. Currently, I am in third year. What should I do? I am also in my third year. You can do CP. That is cool. I mean, because CP is very hard. CP is very hard. So that is why it is good. If you can improve in CP, you will be, I would say, a better a better programmer in general, right? Because you have to be, yeah, very at your nerves. In lead code, the bad thing is that when you are solving a question, you have a lot of time. You are not watching the time, right? You are so mostly you are wasting time. It is very easy to waste time while doing lead code, but while doing competitive programming, you cannot waste your time. If you do, your rating would go down. So that is bad. And I have spent 40 minutes on this question. Even after reading the hints, I'm unable to do this. So the thing is, I have to find a invariance, something that doesn't change in X, something that is common to these things. And if I have a number X and I take its either add it to some other number or take their XOR, that thing does not change. Negative, positive, no, everything is positive, so that is not good. The highest bit, what the highest bit is, no, highest bit can change. In X, if I, in XOR, the highest bit also can change, also can change, also can change. If the highest bit is 1 for both the numbers, then it will become 0. And in addition also, if the highest bit is 1 in both the numbers, it will become 0 only if if there is no carry from the before. If there is some carry, it will become 1. Okay, okay, okay. Let's do some more and look at this. And okay, notice that the operations plus and XOR have the same effect on the pair. Okay, was it actually parity? It is inverted if the second argument if at the end of my X I have 0 or I could have 1, and let's say I take XOR or I take plus when I and the second number also. Shit, how do I create a 3D graph like this? If the second number is 0, if the second number is 1, if the second number is 0 or the number is 1, I have this beautiful graph to represent this. Let's see. Yep. If I take XOR, both the numbers are 0, it will be 0. If I take AND, it plus both will be 0. If I take 1, this becomes 1. If I take add, then also 1. If 1, 1, then 1, 1. And if 1, 0, 0 and 0. Shit, so parity only changed when the last bit was 1. When the last bit, the other number was odd, parity flipped from 0 to from 1 to 0. And the last number was again odd, parity flipped from 0 to 1. Okay, let's do this. Okay, I don't know if this is going to be correct, but we can implement this. Ah, yeah. Here we have this, and what do we do next? It, yep. What do we do next? We We have two numbers. Int s no bool starting x p. Starting x parity is something. Okay, bool flip equals false or equals a 0 and 1. Hmm. Yes, and for int I equals 1, I less than n, and yes, int I will begin at 1. Not flip. If flip is odd, if flip is and, I will have to use some conditional. Flip equals depending on a I and. If a I and true, then not flip, otherwise flip. And x, okay, I am stupid here. Okay, let's call this thing b. Here if x equals, I need to flip x is parity. Yes, x and take x of and depending on, yes, flip. How do I flip? Only the last bit. Zor, shit. Yes, of course. Zor. Take Zor with 1. That is shit. Okay. If yes, x Zor equals, if flip, then take Zor with 1. Otherwise, take Zor with 0. That is actually really good. Can I do this here? Flip this. Flip when x1. Yes, shit. Yes, flip. And now, if x parity equals y and 1, y parity, then Alice see out depending on x parity equals y parity question mark. If that is the case, then Alice, otherwise Bob, and a new line. I don't know if this is correct, and I wouldn't know if this is correct. This is somehow actually correct. Somehow this is correct. Okay. I don't know why this would work and why this would work. Yes. Can you show what is your dressing nvim plugin doing? Wait, I have a ah I'm getting the correct answers there, but not here. And about dressing in Vim, like I use a few plugins and I do not know what every one of them is doing, but I can look it up. Wait, I should know. I actually should know. This is very bad. I should know. Dressing Lua. What does this thing do? Maybe this just makes stuff beautiful. Let's see. I should actually know this, but I don't. Okay, this is by this guy, Steve Eric. This repository was archived and is now only read-only. That is fine. The release of NVIDIA 0.6.6 was very old. We were given the start of extensible code UI, Vim select, and Vim input. Okay. Okay, shit, it does this thing. Okay. I don't even use this. Okay. Yeah, I don't use this. I don't use this. Maybe this is helpful in telescope. I do use this for searching. And is it necessary? Is it a dependency in telescope? We can see the dependencies somewhere. Default mapping, pickers, usage, customization, themes, yeah, contribution. Requirement is just plenary, nothing else. So I don't actually need dressing and delete. Cool. Yeah. Lazy update and where is dressing? Clean, delete dressing. And if I were to go to the question back to the question again, which was fortune telling, this one right here, it is still works. It is still works. So yeah, I do not need the dressing plugin. Just delete it. It does say correct answer, but it doesn't say the same thing there. Submit. Fortune telling. So for snippets, what you use? Snippets for codes like this, this thing at the bottom. I just use a LSP for this, simple LSP, and I have only a few LSPs running. No, LSPs, okay, that is more than few, but I have not configured them. Let me show you actually. And this thing, LSP config, this is a plugin by NewVim itself, and this does all of your LSP plugin configuration. And I am using Clang Lua LSP, Python LSP, and Tailscript. No, TypeScript LSP. Also for it also works for JavaScript. These are the only LSPs I am using, and all the other things that you saw there, they are bad. I don't use LSP. I can delete this. Rust Analyzer, I just was unable to get it working. Yeah, these are the only LSPs I use. And here it is just I have only changed the command which should be used to run the LSP, because on Mac the default LSP is given to you by Apple, and that is not the latest one. So I had to download the latest one using Brew, and I have here given the location for that latest LSP that I want to run. And here is some configuration for running the Lua LSP, for Python LSP, for TypeScript LSP, and for yeah, TypeScript LSP. And since TypeScript LSP uses Node to run, I had to change this to bun because I do not want to use node. I want to use one bun. Yeah, that is the configuration that you can do with your LSPs. Sorry, I wanted to know about templates like you may be using like segmentary or so how you get it quickly. Segmentary like this at the right, abstract syntax tree. Okay, by snippets. If you mean something like this, I got this snippet right here. That is cool. So for this, I'm not using anything. I had to write some code and wait, that is accepted. That is cool. Okay, we can stop the timer at least. And yes, for this, I have a file here. And in this file, I have some CPP files. Here is my code when I want to print some, where is the code? Print vector. When I want to print some vectors, this is the code that I have to write. So instead of writing it every time that I want to print a vector, I have written this script, Lua snippet, which goes into the file, copies all the text from that, and I have a user command here. Yes, some commands I have made a key map. Whenever I press like here, leader POV, the thing that I copied, the snippet would be printed at the current cursor location. Or I could have a user command that I have to type here at the bottom. And when I do that, the snippet would be printed. If that is what you meant to ask. I know about LSP. I think I asked the wrong question. Sorry. Yeah, this one. Okay. Okay. Yeah. So yeah, that is what I do. I have some text files in which I have written my snippets, and then I have some Lua files which go into those text files, copy the text, extract it, put it as a string, and then I use Vim API, this thing puts whatever string I give this at the current cursor location. And this function could be called either as a key map triggered when I press a key map, or I could write it as a command. This function here would be called when I press this thing in the command line, and this one would be called when I press space POV. So that is that, and I have a few of these. And actually, I messed up a little with this one. I would like to change this from POV to what would I like to write? Some. I guess that might have answered your question. Okay, got it. Thanks. Yep, cool. And we did this question. That is cool. I do not understand though why this thing works. I know what this is, but I do not know why this works. Why this works? Why parity? Because parity of both the things could be the same, right? At the start. Shit. Okay. Okay, now it makes sense. Now it makes sense. Now it makes sense why they added 3. In this, it is given that Alice starts with X and Bob starts with 3. If X is even, X plus 3 is odd. If X is odd, X plus 3 is even. Parity changes. So only either Alice's parity equals the target parity or Bob's parity equals the target parity. Shit. Okay. X plus 3. Hmm. Hmm. Okay. X plus 3 was the thing. Okay. Cool. 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 That makes sense. Okay. And for today, that would be the end of the stream. We were able to do 4 questions. That is fine. And yeah, thank you for being here.